And can we switch on your camera, please? So we are starting with pressure in fluid. What did you start in school in physics?
Ma'am, sir is going to start pressure and fluids.
Okay. And in chemistry?
Ma'am, chemistry still not started anything.
Achha. Okay, fine. So after I complete pressure in fluids, then we can do the remaining questions of numericals of the last chapter. Okay.
Ma'am, I saw told that there are some cancellation in this chapter.
Pressure in fluid?
Yes.
Okay. Yeah, I know there are some cancellations. We will not do those for. Okay. So pressure in fluid. Now, when force acts perpendicular or normal to the surface, then it is known as thrust. So thrust is a special kind of force which acts perpendicular to the surface, and that is called normally to the surface. So thrust is the force acting normally on the surface, and thrust acted by a body placed on a surface is equal to its weight. If a body is placed on any surface, then the weight of the body acts as the thrust. So thrust is same in whatsoever position the body is placed on the surface. The thrust does not change because the weight of the body does not change. So thrust exerted by a body on a surface is equal to weight of the body. And thrust is a vector quantity. So first thing is, what is thrust? So thrust is force which acts perpendicular to the surface. So is thrust and force same? Janvi, is thrust and force same? Are thrust and force same?
Ma'am, can I say?
Yes.
Ma'am, no, it is not same.
Not same.
Ma'am, because thrust is same everywhere, but if we do it in different size, the force is different.
Those forces which act perpendicular to the surface will be the thrust. Okay.
Ma'am, can you please explain again?
Force acting perpendicular to the surface. Suppose this is a surface. Suppose this is the surface. And if the force is acting perpendicular, 90 degree to the surface, this force is equal to thrust. But if force is acting in this way, obliquely, this force is not equal to thrust. आपको बात समझ में आई?
So force applies in all directions.
Force applies in all direction नहीं होगा. अगर solids है, तो solids के लिए force acts vertically down. ठीक है? एक wall है. ये wall है. Wall पे हम 90 डिग्री पे भी force लगा सकते हैं. Wall पे हम 40 डिग्री पे भी force लगा सकते हैं. So जो force हम 90 डिग्री पे लगाएंगे, वो force क्या होगा? Thrust. So वही force thrust होगा जो 90 डिग्री पे act करता है. अभी क्लियर हुआ कि आपको पॉइंट थ्रस्ट और फोर्स के बीच में डिफरेंस?
Yes, ma'am.
So when the force acts at 90 degree on any surface, that force is called thrust. 90 degree को हम normally भी बोलते हैं. The force acting normally to the surface is thrust. Ayan, where are you?
Yes, ma'am.
On your camera. So is thrust clear? Okay.
Yes, ma'am.
So what will be the unit of thrust? Thrust का unit क्या होगा? Thrust क्या है?
Ma'am, it is the force which is
Ma'am,
applied
can I say?
externally on
हाँ,
the
so unit of force
Ma'am,
क्या है?
can I say?
Yes,
Ma'am,
I am.
Ma'am, thrust as the unit will be Newton.
Yes, the unit of thrust will be same as unit of force. So unit of force is Newton, so unit of thrust is also Newton. Okay, and force is a vector quantity, so thrust is also a vector quantity. यहाँ तक सबको क्लियर हुआ?
yes, ma'am.
Okay. So unit of thrust. So unit of thrust is same as the unit of force, and so it is Newton. And we know that 1 Newton is equal to 10 raised to the power 5 dyne, because 1 Newton is a force acting on a body of mass 1 kg, producing an acceleration of 1 meter per second square. F is equal to ma, where m is the mass of the object and a is the acceleration. So when a body has a mass of 1 kg and an acceleration produced in the body is 1 meter per second square, then that is 1 Newton. So CGS unit of thrust is dyne, and 1 Newton is equal to 10 raised to power 5 dyne. क्योंकि 1 kg को आप ग्राम में कन्वर्ट करोगे तो 1000 हो गया, and 1 meter को सेंटीमीटर में कन्वर्ट करोगे it is 100, so 1000 into 100, so 10 raised to power 5 dyne. So gravitational unit of thrust in MKS system is kgf, and CGS system is gram force. So they are related. 1 kgf is equal to approximately 9.8. It's equal to 9.8 Newton, which is approximately 10 Newton. And similarly, 1 gram force is 980 dynes, which is approximately 1000 dyne. So now what is pressure? Pressure is thrust acting upon the unit area. Okay, so effect of thrust depends on the area of the surface on which it acts. Larger is the area on which the force is acting, the lesser is the pressure produced. Smaller is the area, the more is the pressure produced. Is this part clear to you? This we have studied in class 8 also. So what is pressure? Pressure is the effect of thrust on the area. Pressure is the effect of thrust on area. More is the thrust, more is the pressure on the same area, and more is the area, less is the pressure on the same area if the force remains the same or thrust remains the same. You are saying something, Janvi?
Yes, ma'am. Ma'am, what's the meaning of effect of thrust?
Like, if thrust is acting, what will happen? What will happen? If there is a force acting normally, what will happen? So that will create pressure. Okay, so force acting on a body will create pressure, and that pressure depends upon the area of contact. More is the area of contact, less is the pressure. अगर एरिया ज्यादा है और सेम वेट रखेंगे तो हमारा प्रेशर कम हो जाएगा. अगर एरिया कम है और सेम वेट रखेंगे तो प्रेशर ज्यादा हो जाएगा. Clear? So look at this. If this is a box, okay, and let's say इसका mass हम लोग लगा देते हैं, like its weight is let's say 10 Newton. ठीक है, अगर हमने इसको broader side में रखा, area ये वाला broader side में, since area of contact is more, pressure कम हो गया क्योंकि weight तो same है, weight is not changing. अगर हमने इसको खड़ा रख दिया, weight is again 10 Newton, but area of contact कम हो गया, so pressure ज्यादा हो जाएगा, है ना? So same thrust, more is the area of contact, lesser is the pressure, and for same thrust, lesser is the area of contact, more is the pressure. Just see, just visualize, एक लड़की flat heels, flat सोल से जा रही है और वही सेम लड़की ने पेंसिल हील पहना है. अगर पेंसिल हील आपके पैर में लगेगा, आपको चोट ज्यादा लगेगी या फ्लैट हील से ज्यादा चोट लगेगी?
मैम पेंसिल हिल,
क्योंकि एरिया ऑफ कॉन्टैक्ट कम हो गया. वेट ऑफ द गर्ल इज सेम, वेट ऑफ गर्ल इज द सेम. अब आप ये भी देखो, एक नेल नीचे से ब्लंट है और एक नेल शार्प है, पॉइंटेड. आप दोनों पे सेम प्रेशर अप्लाई करोगे, कौन सा नेल इजीली जाएगा?
मैम द शार्पन पॉइंट.
The sharper one, because area of contact is less, more pressure is created. Clear? Is this concept clear to you?
Yes, sir.
So pressure is the thrust per unit area of the surface. If the thrust F acts on an area A, then the pressure is given by F is equal to P is equal to F upon A. And pressure is a scalar quantity. Pressure is a scalar quantity. SI unit of pressure, Newton per meter square, which is Pascal. CGS unit is dyne per centimeter square. So SI unit of thrust is Newton and SI unit of area is meter square. So SI unit of pressure is thrust upon area, that is Newton per meter square, and that Newton per meter square is given a special name Pascal. So 1 Pascal is the pressure exerted on a surface of area 1 meter square by a force of 1 Newton acting normally to it. The term normally is very, very important because the pressure which acts normally is only the thrust, and thrust per unit area is pressure. The force which acts normally is thrust, and thrust per unit area is pressure. So 1 Pascal. Okay, can anyone define 1 Newton? Ayan, 1 Newton. What is 1 Newton of force?
Ma'am, 1 meter square, the 1 meter second square.
How will you define 1 Newton?
Find 1 Newton.
Ma'am, can I say?
Yes.
1 Newton is the pressure which is exerted on a surface of 1 meter square.
1 Newton is the
Pressure
which is exerted on?
a surface of area 1 meter square.
How can that be one? What is Newton? Unit of what?
Force.
So how can it be pressure?
Sorry, ma'am. 1 Newton is the force which is exerted on a surface of area 1 meter square.
Why? That is not. What is the formula for force? What is F? F is equal to? F is equal to what?
Mass into acceleration.
Mass into acceleration. अभी हमने definition पढ़ा था. When a body of mass 1 kg, when an acceleration of 1 meter per second square is produced on a body of mass 1 kg, then the force applied is equal to 1 Newton. 1 Newton force is that force which when acted on a mass of 1 kg produces an acceleration of 1 meter per second square.
Okay, ma'am.
So can you all, do you people write down something? What do you people do? You're just sitting and listening? So write down the definition of 1 Newton.
Just a second, I'll be back. Yes, ma'am, I'm back.
One Newton force is the amount of force when acted on a body of mass 1 kg produces an acceleration of 1 meter per second square. So that is Newton. Because F is equal to ma. So from here we are getting the definition of Newton. So what is Pascal? What is 1 Pascal? Who can define 1 Pascal?
Ma'am, can I?
Yes, I am.
Ma'am, 1 Pascal is the pressure exerted on the surface area.
1 Pascal is
The pressure exerted on the surface area.
pressure exerted on surface area of what?
1 meter square by a force of 1 Newton.
Yes, you have to say everything.
Normally,
1
acting
Pascal is the pressure exerted on a surface of area 1 meter square by a force of 1 Newton acting normally to it. So this is very, very important. So 1 Pascal is equal to 1 Newton upon 1 meter square. So up to here, everything is clear.
Yes, ma'am.
So CGS unit is dyne per centimeter square. So 1 Newton per meter square, that is equal to 1 dyne per centimeter square. So, sorry, 10 dyne per centimeter square. 1 Newton, so 1 dyne per centimeter square is 0.1 Newton per meter square, or 1 Newton per meter square will be equivalent to 10 dyne per centimeter square. So force of 10 dyne per centimeter square will be equivalent to 1 Newton per meter square. This is the CGS unit. So this is the SI unit. So if thrust is measured in gram force, and area is in centimeter, then unit becomes gram force per centimeter square. So these are the various units. So SI unit is Pascal, MKS is kg per meter, sorry, MKS unit is kg per meter per second square. MKS यूनिट कैसे आएगा देखो. One Newton is 1 kg to meter into S minus 2 upon meter square. ये cancel हो गया. So 1, so it becomes kg meter minus 1 S minus 2. MKS unit of pressure. CGS unit is 1 dyne per centimeter square. Then there are other units, 1 bar. So 1 bar is equal to 10 raised to power 5 Newton per meter square. That is also equivalent to atmospheric pressure. 1 atmospheric pressure is equal to 760 centimeter of mercury. Pressure of. So that is also equal to 760 mm of mercury. That is also equal to 760 torr. So 1 torr is equivalent to 1 mm of Hg. Pressure of 1 mm of Hg. These are the various units. So कौन से units है हमारे पास? So one is the SI unit. SI unit is Pascal. That is equal to Newton per meter square. That is equal to 1 Pascal is equal to 1 Newton per meter square. That is equal to 10 dyne per centimeter square. That is, so then we have other unit, that is 1 bar. So 1 bar is 10 raised to power 5 Newton per meter square. And we have 1 millibar, uska 1000 part karenge. So millibar is equal to 10 raised to power 2 Newton per meter square. Okay, and then we have 1 atmosphere, so 76 centimeter of Hg. Pressure exerted. Now वो कैसे होता है? एक test tube लेते हैं. This is not in the portion. So we have a test tube 100 centimeter long. We fill it with mercury and we invert in a trough containing mercury. तो फिर जो atmospheric pressure होगा उतना pressure का mercury अंदर रह जाएगा. And when it is 76 mm of mercury, then that is called 1 atmospheric pressure. That is called 1 atmospheric pressure. Clear?
Yes, ma'am.
So once again, what are the various units? It is given in your book also. So the various units, that is Pascal, that is Newton per meter square, that is dyne per centimeter square, that is 1 bar, that is 1 atmospheric pressure, and that is pressure is equal to 76 centimeter of Hg, and then centimeter converted into meter, so 760 mm of Hg, and that is equal to 760 torr. So 1 torr is equal to pressure of 1 millimeter per 1 millimeter of pressure of 1 millimeter of mercury. So if we want to keep the force same, the thrust same, and we want to increase the pressure, what should we do? If we want to keep the force same but want to increase the pressure, what should we do?
Ma'am, can I say?
Yes.
Ma'am, we can sharpen the areas on which we are going to exert it.
Sharpen the area, reduce the area.
Sorry, reduce the area. So that pressure is more, but the force we exerted is the same.
Force is the same, but pressure increases when we decrease the area of contact. So by decreasing the area of contact, we can increase the pressure. So in order to increase the pressure, decrease the area of contact. Always write area of contact. You just should not write area. Because जो contact में आ रहा है pressure के वो ही increase होना चाहिए. So for knife edge, we decrease contact. We sharpen it when decrease the area of contact. Nail tip, we make it pointed, so we decrease the area of contact. So in order to decrease pressure, we increase the area of contact. So school bags ka straps, which come on the shoulder, those straps are broader. Okay, so foundation of high-rise buildings are broader. Slippers are placed under the railway tracks so that area of contact increases. Elephants and camels have broad feet, so the area of contact increases. They can walk easily in sand. Caterpillar wheels are meant for railway for military tanks, so these caterpillar wheels increase the area of contact, and this is how they decrease the pressure.
Excuse me, ma'am.
Yes,
Ma'am, what is caterpillar wheel?
caterpillar wheel, आपने टैंक को देखा, टैंक के पीछे एक चेन जैसा पूरा दोनों तरफ व्हील को कनेक्ट करने के लिए एक चेन जैसा होता है.
Yes, ma'am.
आपने फाइटर टैंक्स देखे, मिलिट्री टैंक्स?
No, ma'am.
मिलिट्री टैंक्स नहीं देखे?
मैम
ऐसे
देखे
इसके व्हील्स होते हैं, ऐसे व्हील्स होते हैं, ये दो ऐसे व्हील्स होते हैं, इस पे टैंक रहता है ना,
हाँ मैम.
इस पे टैंक रहता है.
हाँ मैम.
ये दोनों व्हील्स को है ना चेन जैसे चीज से ऐसे दोनों व्हील्स के बीच में ऐसे कनेक्टेड रहता है.
Oh, हाँ, that no, yes, ma'am. Now I remember. I've seen them.
है ना? तो
हाँ.
इस तरह के व्हील्स को हम कैटरपिलर व्हील्स बोलते हैं. तो फिर क्या होता है, ये जो टैंक है वो इतना हेवी होता है, बट ये एरिया ऑफ कांटेक्ट बढ़ गया ना, तो रोड को हार्म नहीं करता. प्रेशर डिक्रीजेस ऑन द रोड.
Okay, ma'am.
Now, factors affecting pressure. So there are two factors. Because pressure is equal to force upon area. More the force, that is thrust upon area, more the thrust, the more is the pressure. Lesser is the area of contact, more is the pressure. So two factors hai. So area on which the thrust is applied. So more is the thrust, pressure it is inversely proportional to area of contact. Okay. Pressure is inversely proportional to area of contact. More is the area of contact, the lesser is the pressure. And pressure is directly proportional to the force applied. More is the thrust, more is the pressure. Are these factors clear?
Yes, ma'am.
Just see. So, this is the table. If I put a weight of 10 Newton and the same table, I put a weight of 20 Newton. On which table? This is table A, this is table B. Which table is experiencing more pressure? Which table is experiencing more pressure?
Ma'am,
Yes.
ma'am, the B1.
Why?
Ma'am, because larger the thrust, greater the pressure exerted.
Correct. जानवी और आशी आप लोग को समझ में नहीं आई क्या?
No, ma'am. Can you please explain it again?
I am telling that there are two tables A and B, same area of contact. एक टेबल पे मैंने 10 न्यूटन्स डाला, दूसरे टेबल पे 20 न्यूटन्स डाला. किस टेबल पे ज्यादा प्रेशर है?
Ma'am, B1.
हाँ, so that is simple. Now, if I have again two tables, इसका 1 meter square is area of contact, इसका 2 meter square is area of contact, and I put a weight of 10 Newton here, and I put a weight of 10 Newton here. Which will experience more pressure? This is A, this
Ma'am,
is
can I say?
Ma'am,
yes.
what the question is? Which one?
Question is A and B are two tables. One is area 1 meter square, another is of area 2 meter square. Same thrust is acting on both. Same thrust of 10 Newton is acting on both. Which table will experience more pressure?
Ma'am, can I say?
Ma'am, can I say?
Yes, Ashi.
Ma'am, it is the A1 because the area of contact is smaller and the pressure is inversely proportional to area of contact.
Janvi, is this clear?
Yes, ma'am.
I will come to the pressure in fluid. So, what are fluids? Fluids are those substances which can flow. So, air is also fluid. Okay, liquids and air, gases and liquids, both are called fluids. Okay, all the liquids, all the gases, they are termed together as fluid because they can flow. So, fluids exert pressure in all direction. Okay, fluids exert pressure in all direction at all points. Fluids exert pressure in all direction and at all points because they keep moving. Fluids, the molecules keep moving. Now this fluid pressure is equal to what? Force upon area. What is force? Mass into gravity, ma, which becomes g if I take weight. What is mass? Volume into density into the gravity. So that is force. And what is volume? How do we get volume? Volume is area of cross section into the height, into the density, into the gravity. This area and this area gets cancelled, and hence pressure is equal to H rho G. So in liquid pressure is equal to H rho G. Six, 4, 8, 2, 9, 7. So let me explain. So this pressure in fluid is independent of shape and size of the vessel and the area of cross section on which it acts. So अभी तक हमने solids के लिए बोला था कि pressure in solid depends upon the area of contact. Pressure in fluid does not depend upon the area of contact. Pressure in fluid does not depend on area of contact. Let me show you how. See, what is pressure? What is pressure?
Thrust upon area of contact.
Thrust upon area of contact. What is thrust?
Thrust is the pressure which is exerted.
Thrust is force.
Sorry, force.
Force which acts normally.
Hmm.
So force of any substance is equal to weight of that substance. Do you agree this?
Ma'am, pressure is equal to?
No, I'm talking about pressure is equal to force upon area. That is thrust upon area. Thrust is equal to force which is acting normally. Correct?
Yes.
Now, what is thrust of any object is equal to weight of that object?
Yes, ma'am.
What is weight?
Weight is the gravitational pull on the body.
So that is mass into gravity.
Yes, ma'am.
That is mg.
Mg.
Correct?
Yes, ma'am.
Now what is mass? Volume into density.
Yes, ma'am.
याद है ना सबको? What is mass? Volume into density. What is density? Mass upon volume. Mass upon volume, right? So volume into density is mass. हाँ या ना? बोलो.
Ma'am.
Yeah.
Yes, ma'am.
Yes, ma'am.
आप लोग को याद है ये? Mass of any object is equal to volume into density, or density is equal to mass upon volume. याद है या नहीं?
And we remember it.
So mass is equal to volume into density. So हमने mg के जगह पे अब इसको लिख दिया volume into density.
Okay, ma'am.
So this is volume into density. So now we have the formula V into D into G upon A. D can be also written as rho. There is no difference between D and rho. Now, कोई भी 3-dimensional figure होगा, कोई भी मैथ्स में आपने पढ़ा होगा, कोई भी 3-dimensional figure है, any 3-dimensional figure. So that volume of any 3-dimensional figure is area of cross section into the height. Volume of 3-dimensional figure, uniform 3-dimensional figure. Volume of a uniform figure is area of cross section into height. Okay. For example, अगर हमने सिलेंडर लिया, सिलेंडर का एरिया ऑफ क्रॉस सेक्शन क्या है? पाई आर स्क्वायर. हाइट क्या है? h. सो वॉल्यूम हो गया पाई आर स्क्वायर h. गेटिंग? 8th में किया है वॉल्यूम. क्या है वॉल्यूम? वॉल्यूम ऑफ ए cuboid is length into breadth into height, right?
Yes.
So if we cuboid है, तो एरिया ऑफ क्रॉस सेक्शन ये हो गया, ये तो लेंथ हो गया, ये ब्रेड्थ हो गया, ये हाइट हो गया. ओके, सो एरिया ऑफ क्रॉस सेक्शन ये हो गया, लेंथ इनटू ब्रेड्थ, दैट इज द एरिया ऑफ क्रॉस सेक्शन, एंड दिस इज द हाइट. सो एरिया ऑफ क्रॉस सेक्शन इनटू हाइट, दैट इज द वॉल्यूम. इज दिस पार्ट क्लियर?
Yes.
So volume of any 3-dimensional, uniform 3-dimensional figure is area of cross section into height. तो वही चीज हम लोग यहाँ पे लगा रहे हैं. So this is a 3-dimensional figure. So V is equal to area of cross section into height. Density की जगह density, G की जगह G आ गया. नीचे एरिया से डिवाइड करते ये दोनों एरिया कैंसिल. So P is equal to H into density into G. Density can be also written as rho. So P is equal to H into D into G. That can be written as H into rho into G. यहाँ पे क्या है? A is the area of cross section, H is the height, and rho is the density, and G is the gravity. So pressure is directly proportional to H rho G. Any doubt in this part?
No.
Oh, ma'am.
Janvi?
No, ma'am.
So pressure in liquid is equal to H into rho into G. How did we prove? This is a cylinder. It is full. It's filled with water up to the brim. So we know that pressure is equal to force upon unit area, and force is equal to weight of the water. So weight of the water मतलब क्या हो गया? Mass of water into gravity. So pressure is equal to mass of water into gravity upon area. Now what is mass? Mass is equal to volume into density. So mass को हटाया, हमने volume into density लगाया upon A. Now what is volume? Volume is area of cross section into height. अब हम volume को हटा के हमने वहां पे लगा दिया pressure is equal to area of cross section into height into G भी आएगा into rho into gravity upon A. A और A cancel. So H, so pressure is equal to H rho G.
Yes, ma'am, understood.
जानवी
Yes, ma'am. Understood.
पूरा पक्का?
Yes, ma'am.
So pressure exerted by liquid column. Pressure exerted by liquid column is equal to H rho G. और अगर open है, ऊपर का portion open है, so then there will be atmospheric pressure also acting on it. So atmospheric pressure plus pressure due to the liquid column. So that is atmospheric pressure is written as PO plus H rho G. So that is the total pressure acting on acted by a liquid column on its base. क्योंकि अगर ऊपर से खुला है तो atmospheric pressure is also acting on it. Okay?
Yes, ma'am. So if the upper surface is not covered, then we will not add PO. But if it is not covered, then we will add PO to
Yes,
find the actual
if
depth.
it is covered, then they will also always mention, write the total atmosphere, total pressure by the depth of the liquid. So then total pressure will be atmospheric pressure plus the pressure due to the liquid column. And if there is no pressure on the liquid column, if the column is closed, then it will be just the pressure due to the liquid.
Okay, ma'am. So you will tell us in the question only, na, if it is open or not.
Yes, yes, yes. It will be mentioned. So factors affecting the pressure at a point in a liquid. Number one, because we know pressure is equal to H rho G. So पहला क्या हो गया? Height of the liquid column or the depth of the point below the free surface. Then second is the density of the liquid. And third is the acceleration due to gravity. At the same place, acceleration due to gravity will be same. So if we take two liquid columns of same height, then if the densities are different, then the pressures will be different. If the densities are different, the pressure will be different. So can you tell me, I keep a jar of water and another jar of honey, which will apply more pressure?
Ma'am, is honey?
Honey, shahad.
So I'm like saying,
Yeah.
Ma'am,
honey, it will act more.
Yes, pressure due to honey will
honey. Ma'am, honey will act more because it is more thick,
be denser. Density is high.
denser. It is more denser.
Okay. If I have a jar, a liquid column of plain water and a liquid column of salt water. Liquid column of plain water and liquid column of salt water.
Can I say?
Hmm.
Ma'am, then answer will be of salt water because salt water's density is more than plain water.
Hmm.
Salt is included in the water.
Hmm. So salt water, because the density is more, then the pressure will be more. Pressure of 10-meter column of water will be more, or pressure of 15-meter column of water will be.
15.
Yes, because height of water column is more. Clear?
Yes, ma'am.
Yes, ma'am.
Now, laws of fluid liquid pressure. This is very important part. So the first one, pressure increases with the depth. More is the height of liquid column, more is the pressure. More is the height of liquid, more is the pressure. And therefore, the deep sea divers, they wear special suit to withstand the large pressure in the sea. Because as they dive down, the liquid column increases. The seawater column increases. And so the pressure increases. And so the body will get squeezed. So they have to wear special swimsuits. The dams have broader walls at the base. Look at the dam. So the bases are broad. Why? Because नीचे की तरफ liquid का column ज्यादा है, so उसका pressure ज्यादा होगा. So to withstand this high pressure, the base or the bottom of the dams are broader.
Ma'am,
Yes.
could you please again explain the first one?
Deep sea divers.
Huh.
ECA. आप इसके बॉटम में जा रहे हो, है ना? तो ये लेंथ ऑफ द लिक्विड कॉलम ज्यादा हो गया. तो लेंथ ऑफ द लिक्विड कॉलम ज्यादा हो गया तो प्रेशर ज्यादा हो गया यहाँ पे. सो अगर कोई नीचे जाके स्विम करना चाहेगा, तो उसको स्पेशल सूट पहनना पड़ेगा, नहीं तो स्क्वीज हो जाएगा ना एयर कॉलम, वाटर कॉलम से. उसकी बॉडी पूरी स्क्वीज हो जाएगी. सो वो लोग ऐसे स्विम सूट्स पहनते हैं. आपने देखा होगा फुल स्लीव का सब कुछ, पीछे एक वो लेग्स पे भी वो लगाते हैं जिससे रडर टाइप का, स्पिन टाइप का थिंग. सो उससे वो लोग स्विम करते हैं. सो दे हैव अ स्पेशल सूट. दैट स्पेशल डाइवर सूट हेल्प्स them to withstand the large pressure due to the water column in the sea. आया समझ में?
Yes, ma'am.
Yes, ma'am.
Now similarly, ये जो डैम्स है, आपने देखा होगा डैम्स का ऐसे बेस होता है, राइट? नीचे इस तरफ जाओगे तो ये वॉल चौड़ी हो जाती है. ये देखो width of the wall is so thick. ऊपर width of the wall is less.
Yes.
क्योंकि जैसे जैसे नीचे जाता है तो height of water column increases. So when height of water column increases, pressure increases, and pressure acts same in the liquid column. Pressure acts in all direction. तो same वो पूरे की तरफ same pressure act करेगा. तो यहाँ पे pressure ज्यादा है तो ये wall को चौड़ा किया, base को चौड़ा किया to withstand the high pressure. और यहाँ पे pressure कम है. So when वहां पे pressure कम है तो wall पतली होगी तो भी चलेगी. आई समझ में बात? ऊपर का लिक्विड कॉलम कम है, लिक्विड कॉलम की हाइट कम है तो प्रेशर कम है. हाइट कम है तो प्रेशर कम है यहाँ पे. तो यहाँ पे साइड में जो प्रेशर लग रहा है वो भी कम है. तो यहाँ पे थिन वॉल है. लेकिन जैसे जैसे हाइट ऑफ लिक्विड कॉलम इंक्रीज होता जाएगा ये वॉल की थिकनेस बढ़ती जाएगी. ओके.
Yes, ma'am.
Yes, ma'am.
अभी आप देखो, आप लोगों की बिल्डिंग में वाटर सप्लाई टैंक्स कहाँ रहता है? फर्स्ट फ्लोर पे या टेरेस पे?
Ma'am, terrace.
Terrace.
क्यों टेरेस पे रहता है, क्यों फर्स्ट फ्लोर पे नहीं रहता? फर्स्ट फ्लोर से पानी ऊपर तक जाएगा बिना मशीन के?
No.
नहीं, मोटर के बिना नहीं जाएगा. सो the tanks are always on the highest point. So when they are on the highest point, so first floor पे देखो हमेशा water pressure ज्यादा रहेगा, ग्राउंड फ्लोर पे वाटर प्रेशर ज्यादा रहेगा. ऊपर के फ्लोर पे क्योंकि एरिया द लेंथ ऑफ वाटर कॉलम कम हो गया. सो सपोज यू आर ऑन 21st फ्लोर. सो 21st फ्लोर पे वाटर प्रेशर कम होगा. On ground floor, the water pressure will be maximum. The height of liquid column is maximum. यहाँ पे liquid column की height कम है और यहाँ पे liquid column की height ज्यादा है.
Ma'am,
Yes,
what do you mean by the force of pressure?
I'm talking about the water pressure. कैसे नल खोलोगे ना आप, तो ग्राउंड फ्लोर पे पानी बहुत फोर्स से आएगा, बहुत ज्यादा प्रेशर से आएगा. टॉप फ्लोर पे प्रेशर कम रहेगा.
Okay.
Got it? क्यों कम रहेगा? क्योंकि लेंथ ऑफ द वाटर कॉलम जो है टॉप फ्लोर पे कम है और लेंथ ऑफ द वाटर कॉलम जो ग्राउंड फ्लोर पे ज्यादा है.
So we'll be able to see the major difference in first floor and
Yes. If it is a very high rise building, then top floor के लोगों को बूस्टर लगाना पड़ता है, एक स्पेशल पंप लगाना पड़ता है शावर के पास में. ये तो शावर से प्रेशर नहीं आता.
if there are only 10 floors, then
10 फ्लोर्स में इतना फर्क नहीं पड़ेगा, है ना. बट बहुत सारे बिल्डिंग्स में सो दे ऐड अ बूस्टर, पंप, सो प्रेशर इंक्रीज करने के लिए, ताकि शावर से पानी फोर्स से आए. On the top floors, only in the top floors. Now, water gas bubbles rise up, they increase in size. Now, इसको समझो, ये बहुत important है. Gas bubbles increases as it rises up. Let me explain in the other page. Okay. ये एक वाटर टैंक, ठीक है, और यहाँ पे से छोटे छोटे बबल्स निकल रहे हैं. वो जैसे जैसे ऊपर जाएंगे वो बबल्स की साइज बढ़ती जाएगी एंड फाइनली या तो टूट जाएगा या साइज बहुत बड़ी हो जाएगी. आपने कभी देखा है, अगर ये पॉट रखा आपने, उसको हीट कर रहे हो, पानी है, आपको बॉईल कर रहे हो, तो पानी में जो डिजॉल्व गैस है वो बबल्स बन के आते हैं, ऊपर टूट जाते हैं. आपने देखा?
yes, ma'am.
तो ये क्यों होता है? So look at this place. The pressure is more at P1 or pressure is more at P2?
More at
P1.
More at P1. आप ये देखो, एक पिस्टन है ना, एक पिस्टन है, और ये हमने एक पिस्टन को हम प्रेशर अप्लाई करते हैं. अगर हम प्रेशर अप्लाई करेंगे तो ये पिस्टन नीचे आ जाएगा, है ना. पिस्टन नीचे आएगा, इस पे वेट डालेंगे, पिस्टन नीचे आएगा ना, मूवेबल पिस्टन
yes,
है.
ma'am.
तो ये वॉल्यूम कम हुआ या ज्यादा?
ज्यादा. Ma'am, if we push the object
ये पिस्टन है, दिस इज वॉल्यूम 1. अब मैंने प्रेशर अप्लाई किया, तो ये इस पे हमने वेट डाला, फोर्स डाला, ये पिस्टन यहाँ पे आ गया. दिस इज वॉल्यूम 2. विच वन इज मोर? वॉल्यूम किसका ज्यादा है, V1 या V2?
P2.
ध्यान आप हो वहां पे. Let us say this volume is 200 cc, centimeter cube. अब अगर मैंने यहाँ पे प्रेशर डाल के पिस्टन को नीचे किया, वॉल्यूम ज्यादा हो जाएगा. हाँ,
No.
कम होगा ना,
Yes, ma'am.
तो वॉल्यूम डिक्रीज हुआ. So pressure increases, volume decreases,
Decreases.
है ना. तो यहाँ पे जैसे P1 में प्रेशर ज्यादा है तो वॉल्यूम ऑफ द बबल्स क्या होगा, स्मॉल. And at P2 the volume of the bubbles will be big. So as the bubbles rise, what happens? They increase in size. Why do they increase in size? Because this law, pressure is inversely proportional to volume. Okay, or volume is inversely proportional to pressure. So this is Boyle's law. एक साइंटिस्ट है बॉयल एंड बॉयल्स के बाद उसके साइंटिस्ट के नाम पे रखा बॉयल्स लॉ. So this Boyle's law, with the pressure increases, volume decreases. So when the pressure increases, volume decreases. And as we go down, the depth of the water column increases, pressure decreases. Here pressure is less. And hence volume will be less. Sorry, pressure is more, sorry. Here the pressure is more.
As if
Volume
pressure
will
is
be-
more, volume
will be
decreases.
less. Yes, so here small bubbles. जैसे जैसे ऊपर आएगा bubbles, pressure decrease होता जाएगा, size of the bubbles will keep on increasing. वो बहुत बड़ा हो जाएगा क्या? नहीं. After certain point, it will break because वो बबल उतना ही बड़ा हो सकता है जब तक आपका वाटर का सरफेस टेंशन उसको मेंटेन कर सकता है. अगर वाटर का सरफेस टेंशन मेंटेन नहीं कर सकता, then this bubble will break. आपने देखा है, आप जब वो बबल्स खेलते हो, आप जो सोपी वाटर से बबल्स बनाते हो, वो छोटा होता फिर वो बड़ा होता फिर फूट.
Yes, ma'am.
तो जब तक उसका सरफेस टेंशन होल्ड कर सकेगा वो बड़ा होगा, फिर सरफेस टेंशन कम हो जाएगा, उसका होल्ड नहीं कर सकेगा, वो फूट जाएगा. So going back to this slide, so हमने क्या सीखा? हमने सीखा कि when the bubbles rise up, what happens?
Volume increases, but the pressure decreases.
So size of the gas bubbles increase. When
Decreases.
the gas bubbles rise up in water, the size of gas bubbles increase. Size of the gas bubbles increase. Clear?
Yes, ma'am.
Yes, ma'am.
Now, pressure in liquid pressure. Liquid pressure, पहला वाला हमने सीखा क्या कि pressure increases with the depth. More is the depth of the liquid column, the pressure is more. Pressure increases with the depth of the liquid column. The pressure, more is the depth of the liquid column, more is the pressure. So this is a jar, and then outlets are made at different height. So this lowest outlet will throw the water to the longest distance. Why? Because the pressure is very high. So this water jet is less, this water jet is weakest. So the strongest water jet is at the bottom. Okay?
Yes, ma'am.
Laws of the liquid pressure. Second, the pressure is same in all point, at all point in a horizontal plane. एक आपने horizontal plane कट किया तो उस horizontal plane पे ऊपर नीचे आजू बाजू कोई भी डायरेक्शन में the pressure will be same क्योंकि the height of liquid column, the density of the liquid column, the gravity of the liquid column is same. बात आई समझ में? इस point के चारों तरफ height of the liquid column is also same, density of the liquid column is also same, and the gravity of the liquid column is also, gravity at that point is also same, and so the pressure is same. The pressure is same at all the points on a horizontal plane. Clear?
Ma'am,
Yes, ma'am.
why you have drawn that red line in between?
This one, this one.
Yeah, the dotted line.
Yeah, so this is to show the height.
Okay, ma'am.
This is to show this height is constant. ये same height है. पर इसमें नीचे की तरफ से हमने प्रेशर मेजर किया, साइड वेज से प्रेशर मेजर किया, ऊपर की तरफ से मेजर किया, but liquid का column is same. This is the height of the liquid column H.
Okay, ma'am.
The same height remains the same because density is not changing, height of the liquid column is not changing, gravity is not. Clear?
Yes, ma'am.
Yes, ma'am.
These are all very important points. Huh? Now pressure is same in all direction about the point. एक point के चारों तरफ भी pressure same रहेगा. Same reason because the height of the liquid column is not changed. Height of the liquid column is not changed. And by the way, pressure of the liquid column is measured by an instrument called manometer. So manometer is used to measure the pressure of the liquid column. So this manometer, if you are allowed, apply this manometer about 1 point, चारों तरफ से आप check करोगे क्योंकि height of the liquid column is not changing and hence the pressure is not changing. Clear?
Yes, ma'am.
जानवी समझ में आया आपको?
Yes, ma'am.
Ayan?
Yes,
Ayan?
ma'am.
So if this is a point, और ये पूरा liquid से भरा हुआ है, ये point का height of the liquid column is not changing, right? Whether you measure from this side, whether you measure on this side, whether you measure on that side, but about. So एक point के चारों तरफ, the pressure is constant. Are you understanding?
Yes, ma'am.
The height of the liquid column is constant.
So if we measure from right hand side or left hand side, the
Ah.
height will remain the same.
Yes, height of the liquid column is same. So the height of the liquid column is same, so the pressure is not changing.
Yes.
है ना? The pressure depends upon the height of liquid column. If the height of liquid column is not changing, the pressure will not change.
Yes.
Number 4, pressure increases with the increase in density. ये तो हमने देखा. More is the density, more is the pressure. So this is an experiment. एक जगह पानी डालो, water, एक जगह concentrated sugar solution डालो. तो यहाँ पे pressure ज़्यादा है, तो bulge ज़्यादा है.
Ma'am, could you repeat what you said?
So I said pressure increases with the increase in density. Agar density of the liquid column changes, the pressure changes. If I take water and if I take same quantity of sugar solution, so sugar solution, the density is more. And so the pressure is more. And so you see the bulge is more. Here the bulge is more.
So if density is more, the pressure will be more.
Yes. Correct. Because क्या है? P is equal to H rho G. H constant है. तो rho ज़्यादा होगा तो pressure ज़्यादा होगा. More is the pressure if more is the density.
Yes, ma'am.
So the pressure exerted by river water and pressure exerted by sea water at the same height, which will exert more pressure, river water or sea water?
Ma'am, between seawater and
River water, freshwater river and sea water. So where will be the pressure more?
Ma'am,
And
ma'am, can I say?
Yes, yeah.
Yes, ma'am.
Yes. Are you sleeping or what? Janvi bolo.
No, ma'am.
Sorry, Ashi bolo.
Yes, ma'am. Ma'am, इसका होगा sea water, because sea water has many contents in it, so like deposits and everything, so its density increases, therefore the pressure also increases.
So अगर fresh water fishes को sea water में डाल देंगे क्या रहेगी?
Can you please say again?
Freshwater fishes are put into seawater. Will they survive? Freshwater fishes are put into seawater. Will they survive?
No, ma'am.
Q.
Ma'am, because as their body is not used to the high density of pressure, therefore they will float on the on the edge, right? So maybe
Yeah. So this is freshwater fish. Freshwater fish. And इसको हमने लगा
Ma'am, your voice is not coming.
सी का प्रेशर ज्यादा है. The pressure exerted by sea water is more. तो इस पे ज्यादा प्रेशर एक्ट करेगा तो ये बॉडी स्क्वीज हो जाएगी.
Yes.
स्क्वीज हो जाएगी. और वैसे ही अगर हमने सी वाटर की फिश को उठा के फ्रेश वाटर में डाल दिया. सो अब यहाँ पे ये तो इतना ज्यादा प्रेशर एक्सर्ट सहन कर रहा है और यहाँ पे आके प्रेशर रिलीज हो गया तो ये इसकी बॉडी फूल जाएगी और ये बर्स्ट हो जाएगी.
क्यों?
क्योंकि अंदर का प्रेशर ज्यादा है, बाहर का प्रेशर कम है, तो ये बर्स्ट हो जाएगी, फूल के बर्स्ट हो जाएगी.
So, ma'am, both will not survive if they change their.
So freshwater fishes cannot survive in seawater, and seawater fishes cannot survive in freshwater. When freshwater fish is put into seawater, it will get squeezed, and when seawater fish is put into water, it will burst. Clear?
Yes, ma'am.
Yes, ma'am.
Liquid seeks its own level. क्योंकि height of the liquid column same रहेगा. This is a connecting vessel. So connecting vessel का shape कैसा भी हो, height of the liquid column will remain the same. So सब में देखो आप कितना भी liquid का shape column remains the same because the pressure at this end. सिर्फ सब खुला हुआ है, सब खुला हुआ है. So जब सब खुला हुआ है तो सबके ऊपर सेम प्रेशर, एयर प्रेशर एक्ट कर रहा है. सबके ऊपर सेम एयर प्रेशर एक्ट करेगा तो सब कोई सेम लिक्विड हाइट होल्ड करेगा. हाइट ऑफ द लिक्विड कॉलम विल बी सेम, held by all these. And so what happens? Height of the liquid column does not change and hence liquid seeks its own level. So liquid pressure does not depend upon the area of cross section. Liquid pressure does not depend upon the shape and the size of the vessel. Liquid pressure depends upon the pressure at that point, atmospheric pressure at that point. अगर हम atmospheric pressure change कर देंगे, the height of the liquid column will change. So if I pour more water here, then water will equally rise in all the vessels. Equally rise in all the vessels.
But it will slowly rise. No?
Yes. यहाँ से डाला तो इस सब में equally rise होगा. अब कहीं पे भी पानी डालोगे, सब वेसल में पानी बराबर से इंक्रीज होगा.
Ma'am, because they're interconnected to each other.
They are all interconnected. And so height of the liquid column will change. Okay.
Yes, ma'am.
Now transmission, ये इसके पहले. Now, till now, is everything clear?
Yes, ma'am.
Yes.
अब बुक खोलो, 5 मिनट का ब्रेक लो, मतलब अब बुक खोल के 5 मिनट पूरा देखो, and then you get back to me, and then I will explain you the remaining small part.
Yes.
Okay.
Okay.
Ma'am, I'll just go to washroom and come.
Yes. understand? Whatever I have taught, have you understood?
Yes, ma'am.
Okay. So tomorrow at what time you people will be available?
Ma'am,
Ma'am,
same
tomorrow,
time.
Tomorrow, what time you people will be available?
ma'am, 6.
You don't have maths class tomorrow?
Ma'am, don't have to ask.
Maths class is from 7, right?
Yes.
So 6 to 7 available.
Yes, ma'am.
January.
Yes, ma'am.
Okay, fine. So tomorrow 6 o'clock, because I don't want to take so much, but tomorrow ask you whatever I have taught today, I will ask you tomorrow.
Okay, ma'am.
Okay.
Okay, ma'am.
So we stop here.
Bye.
Okay, bye.
Bye, ma'am. Thank you.